Right, hello everyone. We're about to get going. Welcome to today's webinar of testing PLSQL APIs with utPLSQL version 3. We are very lucky to be presented and hosted by Jacek, Gebal, who's the co-author, lead architect, developer and custodian of utPLSQL version 3. Very excited to get underway. Before we get going, I just want to go through a few house rules. If you are having trouble hearing me, apologies about that. If you're having trouble hearing me or if you're having trouble viewing my screen, please just put it into the question box, I can't hear or I can't see, and I will try and get that fixed for you. Today's webinar, we will have content for around half an hour to 45 minutes, and then we will have times for questions at the end. If you do have any questions to ask, please just enter them in the question box. I will then collate them at the end and ask them to Jacek. A few housekeeping rules. We have, so if you do have any questions, we've just gone through that, please do pop them in the question box. I will then read them out to Jacek at the end. If there are any questions that you want to ask privately and not over the webinar, please don't be afraid to email me, which is Hayden, Haydon, .godber, Godbeer, at UKOUG.org. And I can reach out to Jacek following the webinar. If you are unable to hear, please just pop in the question box. If you are unable to see, please just pop in there, I can't hear or I can't see, and we will try and resolve the issue. Following the webinar, I will send out a recorded copy to everyone who has attended. You can then reach out back to me with any questions that you want to ask Jacek privately as well. There will be a poll that will be announced shortly after we finish, just before we start the questions. It's a very short poll and it's just about a part 2 webinar series and what you would be interested in seeing, but we can get back to that later. If you have anything else, any questions, like I said, just pop those in the question box and I will get answering to them. I am now going to hand you over to Jacek, and bear with me. Who should now have taken over. Yeah, Jacek, are you online?
Yes, hi, welcome everyone. My name is Jacek Gebal. I'm a principal software engineer for Fidelity Investments, and as Hayden said already, custodian, author, and lead architect for utPLSQL version 3. Probably you can see my slide already. So you see my Twitter handle, email address, and blog, which isn't really an active blog, but I always plan to go back to that. So here it is. Few words about me. I'll just disable my video so you can see the slides on the full screen. Should work now. So I'm a software engineer since early 2000 and mainly Oracle house, so Oracle database, PLSQL, SQL. I got infected with testing and automations in 2013 when I joined Pragmatists, which is a software house in Poland. Poland is my home country. And as I said already, I'm tightly coupled with utPLSQL 3 at the moment. I'm still an active developer, learner, and trying to be a testing advocate. So let's see how it goes today. Right. So what's the plan for today? Well, first of all, I'd like to talk about why. And why is the most annoying and most fundamental question that you might hear. And it's often asked by children. So why the sun is shining, why the moon is round, etc., etc. Those questions seem silly, but they are really, really fundamental. The children ask those questions to get fundamental answers, to understand the reasoning behind things around them. So why is really the key question to ask when you think about testing. Why do we test? And that's actually the first question to ask before we say, okay, so now I know why to test and what should I be testing? And maybe when. So when is the right time to do the testing? And of course, once you have all of those answers, then the fundamental question is how. So how do I test PLSQL? How do I test database? So why test? And I guess each and every one of you already has some answer in your own head, and one of the possible answers you might get is, well, I want to test so that I can find bugs. And that's one way to think about it. But when you think about finding bugs, you actually doom yourself for the negative thing. You think about something that will happen. So you expect bugs. And when your team is driven to find bugs in your software, when you have QAs that are driven to find bugs, well, if they don't find any, maybe they are no longer needed. So the reasoning behind testing to find bugs isn't really the best reasoning. If you flip the coin, actually, and think about the other side, well, actually, you might test to check that the software works. And that's much better thinking than thinking about finding bugs. So you want to check that what you've done is the right thing. But then what does it really mean that it works? This statement, the answer, why do we test, check that the software works, isn't really the best way to think about it because it's vague. It doesn't give you actually definition. What does it mean that your software works? So when you think about a bit deeper, what your software is supposed to do is to deliver solutions that meet requirements of your users and meet expectations of your customers. So your tests should be proving that. Your tests should be proving that the solution meets requirements and expectations. And not only that, actually, when you have your tests, you want to prove that whenever you change your software, everything that worked so far is still working. And that's one of the biggest advantages of having automated test suite, that you can just run it and see that everything is working fine. I'll talk about it a little bit later. And now one more benefit that you can get out of tests, if you do them right, is that your tests actually become examples. And those examples are showing how the software is to be used. And so they actually document the requirements and become a living documentation of your source code. So they reveal the intention. They say what the function, procedure, or view is supposed to give you. Now, there are companies and there is software that generates tests for you. And I saw a couple of those. And the one thing that strikes me when you think about how those automated test generators work is, well, they generate tests. And to generate tests, they need to generate it from something. So they generate it from the software. So the tests are generated from the software that's already in place. And that means that they are created for that software. Going further, actually, the only thing that they can confirm is that the software does stuff, well, does whatever it is doing. And I don't know if it's good or bad. It is just working as it is working. So that's the big flaw. And also, so you don't get any confidence that the code does the right thing because, well, the generator doesn't have any idea about what is the right thing that is supposed to be done. It has no reference to the requirements because, well, the test generator is working on your software. It's not working on your requirements. So when we look at those reasons why, which I coined out before, what can you get with automated test generators? Well, actually, they won't find bugs in your existing software because they just confirm that the software works. They don't prove anything related to the requirements because they have no idea about requirements. And so they also don't give you any sense of documentation, or they don't reveal any intention behind your software. They just simply provide information that software works. And if you have those tests generated, the only benefit I think you can get in the short term is that they will prove that the change didn't break existing functionality. The trouble is, however, if the change will break the existing functionality and some of your automated tests generated automatically fail, you need to understand what the test is actually testing and what the code is actually doing to figure out what was broken. And with those automated test generators, those tests aren't really as valuable and as readable and understandable, so that you can understand, okay, now I know this is broken, and what this thing that has broken is often hard to figure. So I guess when we think about testing and why do we want to test, we should think about providing on confirming that the requirements are met. So what do we test? What do we test in the database? And in general, you should be testing anything that has any logic in it, any behavior in your database. And I hope you're using smart DB paradigm, or you do build your database through APIs. You use PLSQL, and so this PLSQL has some in and out structures. So you have input parameters, you have output parameters, you return data through objects or ref cursor. So definitely you should be testing all of your logic in PLSQL. You definitely should be testing all of the input and output structure. And maybe sometimes you should be thinking about testing state, which is data in your database. But be very careful about it, because the data is one thing that's constantly changing. So when you think about testing state, don't rely on it too much. Just rely on the things that are really core of your business. So let's say you have a dictionary table with gender, and well, the gender should always be male and female, and you don't want to have any other data there. So you might want to check this state, not anything that's actually constantly and continuously changing. And when you're testing, it's quite an art, and it's not so easy to avoid over-testing or under-testing. So under-testing meaning that you actually leave gaps. So if you find something hard to test, you will just not test it. And if you don't test it, then you have no confidence that it actually works properly. On the other hand, over-testing is like testing the same thing 20 times with 20 different tests. That is just a waste. And flaky, unstable tests are one of the things that could move you away from testing at all, because if your tests don't always pass and you don't know why, well, nothing has changed, but they fail, and sometimes pass, that's something that you really need to be careful when you're writing tests, so that those tests needs to be stable. And testing needs to be fast. If your tests run slow, you just won't execute them whenever you want. You will say, oh yeah, I'll run them at the end of the day. So if your tests aren't fast enough, you won't execute them often enough. And that's the main thing about testing. You should test your code as frequently as you like. And I definitely don't encourage you to test the code you don't own. And by code you don't own, I mean it belongs to a different vendor. It's vendor specific. So try to avoid doing that, because you're not responsible for testing that the code that was delivered by vendor is working fine. You might test that you can integrate with it, but that's it. Don't test what the vendor code is doing. So when to test and how to test? Well, when? There is 3 simple words for it: test early, test often, and test automatically. And early is as early as possible. With test-driven development, you actually test before you write your code. Often is every few minutes, every few seconds, depends on how long is your cycle. And automatically, well, whenever you integrate or whenever you want to deploy your changes, you should always run your full test suite so that you test the whole system and make sure that everything works as expected and nothing was broken. Unit tests are first, and that's a really nice way of putting it, because the unit test needs to be fast so that you can execute them really, really quickly whenever you want, without hesitation, without delay. They need to be isolated, so every single test is an isolated example that doesn't depend on any other test. Doesn't depend. So when you add 5 tests, you can remove any of them and run them in any order, and they don't depend on one another. They need to be repeatable. So each time you run a test and nothing has changed in your system, the test should be passing. And if something was changed and the test is broken, each time you run it, it should be still broken. They need to be very stable and repeatedly give you the same answer. Self-verifying. So the test needs to be written in a way that it's obvious. So when you read the test, you know what it is testing, and you know what the code that is tested is supposed to be doing. And also, they need to be obvious to understand that when they pass, you know what functionality is working. When they fail, you know which functionality isn't working. They need to be thorough, so they should cover all of your system, and timely, so you need to write them right away, not 2 weeks after you finished coding, or a month after, or 2 months after, at the end of the waterfall cycle, when you finish your building your whole system. That's way too late for testing. And the reason for having tests written as soon as possible is that the longer you wait, the more software you build. And the more software you build, the more risk of having bugs or missed functionality. So the more you wait, the more the risk grows and the more bugs or issues you might find. And so when you find bugs, what happens is you go back and you fix them, and then you test them again and go back and fix them. So running tests early gives you the benefit of having less code to fix if you need to fix anything. So I mentioned test-driven development, TDD, as a practice, and it's a very short cycle of development that consists of 3 phases. The first phase is a red phase. And so you start by writing a test. You write a test from your behavior, from your requirements. So you get a requirement, you convert that requirement into something that you can write as a test, or you name that requirement in a way that it is an example. So you write a test. There is no functionality, so you see the test fail because the code is not yet written. You keep those tests simple and small so that they become examples and they become the documentation of the functionality. Now, once you've finished your test and you see the test failing, you know that the test will fail if the functionality is not there, or the test will fail if the functionality isn't working. So then you go to the green phase, where you actually try to do as little coding as is needed for the tests to pass. So you write a small test, then you write functionality that covers only that test, not that test and few more. You don't go ahead. And if you get stuck, you just undo and start over. So you have that test in place to see if your functionality is working or not, even before you start coding. Now, one thing happens when you have that. When you have the test and the test is failing when the functionality is not there, and then you build the functionality and the test is passing, what you get is that you are safe to change the code after you've implemented it. So if you don't have that test and you've written your code, you don't know if you can safely change it or not, because, well, you kind of tested it manually. Probably you compiled it, you did run it to see if it is giving the expected results. That's anyway what I would be doing if I wouldn't be doing test-driven development. So I run my code manually to see if it's doing what I think it is doing. And once I'm happy, I say, okay, now I can ship it. The problem is then when you finish coding, you cannot change it. And in test-driven development, the most important part is refactoring. So once you've finished coding and you have your test passing, you can safely remove duplications, reorganize your code, rename variables and clean up, restructure it however you want, because you have tests that will prove that each time you refactor, the code is still working. It is still doing what it is supposed to do. So you didn't change the behavior. I think the refactoring or safety of refactoring is the biggest advantage of test-driven development. Now, imagine that you do it just for one requirement. So your coding or your cycle is very short. Just go ahead and repeat the cycle over and over and over again. And by the time you're finished, you have a suite of tests and a code that's complete. And you say, yes, I'm done. Each time you create a new test and you create a functionality for it, you get a feeling of accomplishment. You get fast feedback loop. And you see the progress of your work as you add more tests. Right. And for those of you who've never tried it, it might seem very abstract. So let me just try to show you how you can actually do it in PLSQL. So I have a schema UT3 demo, and I'll be creating a utPLSQL function that is to create rooms. My requirement is to have a functionality to create rooms in my database. Let's just start by creating an empty suite. So a utPLSQL test suite is nothing more than a PLSQL package that is annotated with a suite annotation. You see this --%, that's annotation, and suite is the keyword. And then I added a comment saying what that suite is. It is a suite to test the create room functionality. So let me just go ahead and do that. And now to run my tests, all I need to do is to execute the UT run procedure in that schema. So when I run it, I see, okay, there is a create room suite, and it has 0 tests in it, and it's finished. So let's actually add a test for my first requirement, and a test would be nothing more than a procedure without any parameters. And it is annotated with a --test, the %test. And I put in a description that actually is the test case. It's the requirement. So my requirement is that my functionality should create a room with a given name and return its ID. So let me just create that test suite again. Now let me see what happens. If I run this, well, oops, my test has failed. And you see it failed here. And it gives me a reason why it failed. Well, it failed, of course, because I don't have package body. So let's go ahead and create my package body. And we are still in the red phase. So of course, my test should be failing because I don't have the create rooms functionality. So if I compile my package body, what happens is that the package is compiled with compilation error. And if I run my tests, they still fail because the package body has errors. But what happened here is I actually defined the API. I defined what the create room function should look like. Well, the create room function, first of all, is a function because it is returning something, and it's returning the room ID, which is an integer. And it has an input parameter, a room name, which accepts some kind of string, so a varchar2 variable. So just this little piece of test already defined the API. And that's a really good starting point. So you start from how this will be consumed. So let's create the function. And I won't create the whole thing already. I'll just start by creating the function, which is empty. So you see that should satisfy what I have done so far in my test. If I run my test now, you see, well, it finished. And it is 1 test, 0 failures. Nice. Though the test isn't proving anything else except for the fact that the function is there and it has the expected structure. So it returns an integer and accepts a varchar. So let's expand our test to make it actually test what it should be testing. So what I want my test to do, what I want my function create room to do, is to insert something into rooms table. And it should actually insert a name that I have provided. And that should be associated with the room key, which is returned by the create room function. And here is a new thing showing up, which is the expectation syntax. So what my test will be testing actually is it will be checking that the room name in the rooms table is living room. And that's because I called my function with the living room as parameter. And when I compile it, well, a new problem shows up because, well, I don't have the rooms table, right? And you see this exception showing here, table review does not exist. And I can still run my tests, and it will say that the package body has errors. So that means there are problems with my tests. But one more thing happened again. You see this select statement that I used here actually defines what I want in my table. Well, the table name should be rooms, and it should have a name column, and it should have a room key column, and the room key should be the integer that's returned from here. And the name, well, is the name that I passed here. So I create my table. I'll create it with the room key as a identity column and add room pk as a primary key constraint. Right, so now I have my table created. My test should no longer have compilation errors. So let's see what happens. If I run my tests, they still fail, well, because there is no data in the table. Of course, there is no data in the table because the create room function that I created is nothing more than a skeleton. It has no body. It does nothing. It is just an API. So I'll create some functionality in that function now. The function will actually insert into the rooms table the name that is passed in as a parameter, and it will return back the room key, which is generated as an identity. And that's it. So let's compile this function, and you see my test is passing now. So within a few minutes, while talking to you, I have created a function, and I created a test for a function. I've proven that the test will fail under multiple circumstances, and I have proven that the test will pass if the functionality is in place. Now I could go on and create a bit more, but I know we are quite short on time, so let me just go through one more. So another functionality would be that the function should throw an exception when we pass in a name that's null. We don't want to store a name with a room without name. So let me compile that one, and I'll create a body for it. And now testing for exceptions with utPLSQL is quite easy because actually you use the throws annotation, which says that the test will throw an exception. And you provide exception number or exception name or exception variable name in the throws as a parameter. So this is my test body. I'm just calling the function with null. That's all that there is. I'm calling the function with a null as an input parameter, and the assertion is done through the throws annotation in the package spec. So if I compile this and I run it, well, the test has failed because we expected this function to throw an exception, but nothing was raised. So you see, if the exception was not thrown, utPLSQL will fail with an exception, with a failure. And it didn't throw an exception because there is no not null constraint on the name column. So let me just add it. And if I run my test again, the tests are passing. So you see, actually with utPLSQL, when you do it right, you can even test behaviors that are decided by things like the database constraints. If I would disable this constraint now, that could have serious impact on the way my system works. And so making sure that the constraint is in place, or the functionality that is decided by that constraint works as expected, might be important. So that was a very silly and very simple example, right? We could have add much more to that, but this is how you can start. You can start by building something simple, take baby steps, and add more and more and more as you go. Build your tests example by example, requirement by requirement. That's the ultimate and the only right way to build your unit tests. If you try to build too much, you will fail. And of course, you can go through some other examples, and I have those already implemented. I have a function that, a procedure that is removing rooms by a name, and I have a procedure that will allow us to add content to a room. So we have a data model here with the room table and the room contents, and the contents will look, there can be multiple elements in one room. So why utPLSQL? Well, first of all, we've created it as engineers to use for ourselves because we saw that what's on the market is not meeting our requirements. It's free and it's open source. It's fully tested, so we use utPLSQL itself to test utPLSQL framework. It's compatible with Oracle 11 up to 18. Well, if 19 comes in, we'll probably be compatible with that as well. It's independent of IDE, so you can run it with anything that you have, whether it's SQL+, Toad, PLSQL Developer, SQL Developer. It has a command line utility so you don't even need to have any SQL client to run it. We have Maven plugin, so if your projects are mainly Java-based, you can integrate testing of PLSQL into your Java build. Tests are described by annotations and expectations and nothing more. So you saw those comments in the package spec, those are annotations. The utExpect syntax that I showed you in the body is the expectations. So it's pure PLSQL. There is no additional tables to populate, so that your PLSQL tests are just PLSQL packages. So they can live with your source code in your version control system. And they can be simply compiled into the database. And if you have the framework installed, you just run them. No extra setup, no migrations between databases. And suites, so the test suites are created on the fly. We detect that the package that you want to run is a test suite, and we just run it for you. We have automatic transaction control in our suites, which I'll demo in a moment. So you don't need to worry about cleaning up the data after your tests. Your tests are isolated and independent because of that. And one quite unique thing about utPLSQL, it is data type aware. So data types are important. You don't want to say that a date and a string is the same thing, or a number and a string is the same thing, which kind of happens in Oracle PLSQL by default because there is the implicit data conversion. utPLSQL overcomes that, so when you compare your data with utExpect, it is data type aware. So the core of utPLSQL is suites and the annotations and expectations. And to run your tests, you use utrun syntax. And the utrun is not just a procedure without parameters. It actually has quite a few parameters that you can pass in. So it's multiple options. Maybe we'll go through those if we have time. About annotations, there is a nice documentation in our user guide, so you can have a look at that. There are two types of annotations. There are package level annotations and procedure level annotations. So the test, as I showed you in the example, is the procedure level annotation. It is annotation that is associated with procedure, and package level annotation is associated with a package. So it's worth to note that those are there, and they actually impact the behavior of your tests. So you can, for example, disable the whole test suite, or you can disable individual tests in your test suite. You can define or organize your tests into suites or test packages into suites by using suite path. The default behavior of automatic rollback can be disabled by using the rollback manual annotation. You can define display name for suite, and you can do the same for the test and for the context. Contexts are kind of subgrouping of your tests in a test package. Additionally, if you want to do some data setup before all of your tests, you can use the before all procedure annotation, and if you want to do some kind of cleanup actions after all of your tests, you can use after all. And sometimes you want to do something before each and every test, so you can use the before each annotation, and the same goes for after each. If you have test specific setup, you use before test and after test for those. utPLSQL expectations support multiple data types, and those cover almost a full set of data types available in Oracle PLSQL. So we have number, varchar, date, boolean, club, blob, timestamp in all of its flavors, and interval in all of its flavors. We support also comparison of cursors, also with the same exact syntax. So you can compare cursor variables using utExpect, object types, nested tables, and arrays. So the compound data types are also supported by utPLSQL in the same way as we support the scalar data types. So what kind of expectations do you have in utPLSQL syntax? I showed you the utExpect value to equal, but there is more, and not only we can compare that something is something, we can also do an expectation which is negated, so we expect something not to be something. And we have multiple matchers, so depending on what you need to test, you can test that something is equal to something, is null or not null, true or false, is like, so you use a like operator to compare texts, or you can use regular expressions. You can test for count of cursors or count of collections. You can check that the cursor or collection is empty. You can test that the data in your integer is between upper and lower range, and check if something is greater or less than. We work on more matchers to come, so you see the include and be within are still worked on, but we think about new ways to compare data, so the matchers are being constantly extended. Now, I mentioned that we are data type aware, and when you compare data in your tests, you really would like to know that 100 is a number and it's actually equal to 100. It's not equal to 100 as a string, because you cannot add to a string another string. You can just do this with numbers, and vice versa. So a blob and club is not the same, or a varchar2 and club is not the same. They are handled differently. And a timestamp without time zone and a timestamp with time zone is different. So when it comes to unit testing, we say data types matter, and those comparisons are not valid. So we will say, well, this is not true, and the test will fail. So 100 is not a 100 string. So let me go quickly through organizing tests into suites. I'll just create my examples here. So what I have done is I created the rooms table again, created a between string function, add rooms, contents, and remove rooms by name procedures, and then I added tests for those. Now, if I run my tests again, we see a bit more. And so I have much more tests now. I have 15 tests, and 2 of them failed, 1 of them errored, and 1 is disabled. So let's go through that quickly. First of all, you see something new, which is a nesting of the test results. So you see we have remove rooms by name, which is part of test rooms, which is part of demo, part of utPLSQL, part of org. So if I open that particular test suite, what you will realize, remove rooms by name, I used a suite path. A suite path organizes tests into groups. So you see the remove rooms by name is part of test rooms, which is part of demo, utPLSQL, org. And all of the tests that share the same suite path will be grouped under the same elements. So it's kind of like putting your files into folders. Each and every element after the dot is like a subfolder below it. So if I open the create rooms, we see, sorry, not this one, add room content. You can see it is sharing the same suite path. But there is one more interesting thing, which is the test rooms. And if we see test rooms is actually a package. And it has a suite path of org utPLSQL demo. So actually those two test packages are part of this test package. And this test package has a before all, which is a shared setup of the data that will be shared across those two tests that are executed within the test rooms package. So you can do your setup once and use it in multiple test packages if you want to. And one more thing that I would like to show here, which is quite interesting. Let me just open the test rooms package body. If I run this test over and over and over again, they always fail the same way. We have 15 tests, 2 failed, 1 errored. And don't worry about the failures, that's for the purpose of demo. But you see the setup rooms is setting up the data in 2 tables. I never clean it up. I never remove the data. Even more, if we look at the add room content, these tests actually add something to the data because they call the add room content. What happens is that utPLSQL makes sure that each and every test runs in isolation from other tests with the automatic rollback. So whatever is changed within the test will be rolled back to the moment from before the test. And whatever was changed in a test package will be rolled back to the state from before that test package. And it goes up and up through the suite path. So the test rooms setup is visible for both of those, but the add content to a room test suite is not affected by changes done to the data by this suite. So that way we maintain the isolation between the tests and make sure that one test is not impacting another. Okay, moving on. I told you about the UT run and that you can just execute your test by doing the UT, using the ut.run as a way to run your tests. But there is far more to it, and I'm not saying that you need to use it, but it's good to know that it's possible. So you can run just one specific test by just putting in the test package name. If I run this, it executed only the tests from this function, from this package, between string function tests. Now I can say explicitly I want to run the tests for a given user. So if I pass in the username, it will run all the tests for the current user, which are those 15 tests that I showed you before. I can also say, well, I would like to run the tests for another user, and if you don't provide any parameter, the default is the current user, so current schema. So if I switch the schema and I run the UT run, well, it runs 0 tests because there are no tests in this schema. If I switch the schema back and I run it again, I go back to those 15 tests. I can also run single test procedure, which is kind of handy if you are working on a test. So if you work on a new test, you might not want to run all the test suite, but just run single test. And that way you can just provide the test package name and the test procedure name and run just single test. And if that test is in a different schema than your current schema, you can also use a schema as a prefix here, and it will still run the single test. Something didn't work. Ah, yeah, because exec cannot be done in multiple lines, sorry. There you go. And then you can also pass in a list of objects to your test. So if you would like to run 2 different test packages only, you can just pass them as a list. So you do UT run, pass in the list of 2 packages, and if I run it, it executed 10 tests, and it executed tests from the test rooms, and it executed tests from between string. And I showed you the suite path as a syntax. You can actually reference the tests that you want to run by a suite path. So if I want to run everything from org utPLSQL, I'll just run this. And it will run everything that's nested under org utPLSQL switch path. And of course, I could go deeper and say, well, I would like to run just test add room contents from that the switch path. And that still works. And to make it even more funny, you can run this as a select statement. So you can run your tests as a select statement to get the results into your data grid. What I've showed you so far is just one format of the report or outputs. So you always get this text output with the finished at the end. But utPLSQL has multiple reporters to support integrations with outside world. And if I want to run with a different format, I just use documentation reporter, which is the default. I can use XUnit reporter, which is providing XML. And I can mix those options together. So I want to run a single test with different format. There you go. And we have also code coverage. And I actually will try to demo it here. So let's say I'd like to know how much of my code is covered with my tests. I'll run it from utPLSQL SQL Developer plugin extension. So I can just run the test by right-clicking on a test package here. And when I run it, it will show me what is the coverage. It shows me that the coverage is 100%, which means all of the lines, and there are just 2 lines here, have been covered by the tests. If I try to do the same for a different function, I get a different result. So my create room is also 100% covered. And let's try it with remove rooms by name. Oh, there is only 80% coverage, which is, well, 1 line is not really covered with the tests. So that's a nice indication of how thorough your testing is. Just don't get too bound to the test coverage, because that's not a real metric. The real metric is your confidence. So are you really confident that all of your tests run properly? Let me just go back to my slides and see what else do we have here. Oops, I think I did something wrong. Yes, so we had a look at the test run options. Now, I know we are almost out of time, so I'll just quickly show you that we actually have a utPLSQL client, which provides you with the same functionality that I showed you, or even more actually functionality. So all I need to do is just execute the tests providing the connection string, and I use the -c option here so that my tests are executed in color. So the report is shown in color, and you can see a bit more readable outputs here. So you see the green ones are the tests that have passed, the red ones are the tests that have failed, and the yellow one is the test that is disabled. So that gives you much more readability when you run your tests. And the client is one thing that you can run from anywhere. So you can run it from Java, Windows, whatever you want. And that's a really nice way to use your to integrate your tests with CI/CD frameworks or continuous integration, continuous delivery. And you get actually the same thing when you run your tests with our Maven plugin. So I use Maven test, and I provide my credentials and database URL. And when I run it, it again executes the same tests on the same database, but just using different framework. And when you go, if you use any CI/CD servers, let's say Jenkins is one of the ones that I tend to use. Just by using the utPLSQL client as a command line utility, you can execute your tests and integrate it nicely with Jenkins. So when I run my tests, when I execute this project, what we get is code coverage report, which is integrated into Jenkins, and we can see the same metrics that we saw in the code coverage as a HTML report. And also we get a test results trend, so we see how many tests we had and how many of them have been failing. And we can also navigate into details and see how many times in a row this test has failed, what were the exceptions for an individual test. And as well, you get the duration for particular test suites that you look at, and number of tests and number of failures. So going back to my slides again. I think I went through all of those items that I wanted to show. Now, there is a cheat sheet, so if you want to learn syntax of utPLSQL in a quick way or have a quick reference, this cheat sheet might be actually helpful. It's a 2-page PDF, so you can even print it out and have it on your desk if you want to learn utPLSQL. We have a documentation page with documentations for every single version and every single release we do. And the project page itself contains different projects. So you have utPLSQL, the core framework, the SQL developer plugin, the utPLSQL client, and Java API Maven plugin. So I think that's it for now. If you have any questions, feel free to contact me. And Hayden, I don't know if we had any questions during the session.
Yes, we did. The first thing I'm going to do really quickly is we just wanted to push out a quick poll, as Jacek and I were discussing whether we should host a part 2 of this webinar. And we were keen to get, if you attendees did want that to happen, we were keen to get your opinions on that. I'm just going to launch it now. So that poll should open up to everyone and you should be able to answer. I'll just give you all a couple of moments to answer that. Lovely. Fantastic. Thank you, everyone. Just moving on to some questions as well. We did have one question come in. That's it. And it's thank you for the lovely demo. Can you please briefly explain how we can use utPLSQL for any enhancements / bug fixes done for a maintenance project? In such cases, utPLSQL code should mimic the entire API being called. Did you want me to repeat that?
Yes, please.
No problem. So can you please briefly explain how we can use utPLSQL for any enhancements, bug fixes done for a maintenance project?
Yeah, so actually, I demoed test-driven development. And in fact, one of the things that I discovered that is the best way to learn or understand the benefits of test-driven development is to start by bug fixing. So when you have a bug in your software, and let's say you have 0 tests, the first thing you do when you encounter a bug is find a way to reproduce it. So the best way to reproduce a bug is to write a test that confirms there is a bug. And that test should be focused only on the functionality that's reflected as a bug. So then once you have that test created, what you can do is fix the bug in your software and see the test passing. Now, I know that writing tests for legacy projects or tests where you actually have a software already in place, and I guess that's the place we all are in to some extent, is a big challenge. It's a challenge because, well, if you have 0 tests and you want to suddenly go up to, let's say, 10,000 tests or even 1,000 of tests, you won't do it, overnight. It's something that will take time. But if you think about all the benefits you get from that, doing it, piece by piece, each time you touch on a functionality that you change might give you benefit. Actually, it will give you benefit, and it won't kill you. Because if you would spend half a year writing tests, you would definitely hate testing.
The other part to that question was just saying, in such cases, utPLSQL code should mimic the entire API being called. Is that the case?
Well, I say I use different approaches depending on the complexity. If your API is, well, actually, you might think about few aspects of testing API. One would be to say what the API is, and as you saw in my demo, my first step was to call the function, right? And that was kind of documenting what the function is. So the test was saying, oh, this function should accept those parameters, and that's the first phase of your test. Now, if your function or API is doing a lot of things and it's very complicated or very complex, it might be beneficial to write multiple tests that test different aspects of this API or different aspects of behavior. So let's say if you have 20 parameters, you might end up in a situation where, for those 5 parameter values, there is one behavior. So there is a different flow in your API. So your tests will depend on the flow or different branches of if statements or different branches of SQL statements that you have in your API. The way you test should be done in a way that everything that every logic that is in your API is covered by tests, and it's best to divide it by business functionality, so that your tests document business logic somehow, or the logic is reflected as business requirements.
Excellent. Another question that we had was, is there a way to split data inputs and expected values from test code?
One of the things we are working on, or actually it's an idea, it's not yet being worked on, is to allow utPLSQL to have test parameters. So that way you could have tests, the test annotations would allow you to call the same test with different input parameters. Now, even without that, you can still do it. And if you look for inspirations, there is the utPLSQL. I don't know if you can see my screen. Am I still sharing? Or is the poll showing on the screen?
So let me try and bring that poll down.
So if you look for some examples or different ways of testing, utPLSQL itself, as I mentioned, has
you should be back
as a thorough. Yes, I hope I am. utPLSQL project itself, so GitHub utPLSQL has plenty of tests, and you can have a look at how we test different aspects of our framework by using utPLSQL. So there are some elements that we test very thoroughly using different input values and expecting different output values, and that can be done quite easily with utPLSQL. It's probably requires a bit of creativity in the way you work. Sorry for not being more specific, but maybe if we would see a piece of code as an example, it might be easier to talk about it.
Fantastic. Okay. Does anyone have any further questions they would like to ask? Please do just type them in the question box so I can read them out. If not, do remember that a copy of this webinar recording will be sent to you all afterwards. You also have Jacek's contact details, but I can again include them in the email afterwards so that you do have them. If there are any more, I'll just allow another minute for any more questions that want to come through. Okay, I think we should be good there then. If you feel that there is a topic that you would like to see discussed that wasn't on the poll as well, once I send the email out afterwards, the post webinar email with the recording, please do just reply with what sort of content you would like to see, or if there's any further questions that you want to ask Jacek, please do just reply to that, and I can make sure that he gets it, and hopefully we can do a part 2 to the webinar. Thank you all for coming today. If you do want to visit any or come to any other webinars or events that we have, please do just go online to www.UKOUG.com/calendar, and that will show you everything we've got up and coming. And that is it, I believe. Have you got anything else to add, Jacek?
No, I just wanted to thank you all for participating, and thank you, Hayden, for hosting this webinar. I hope to be able to do it more often.
Yes, I hope so too. Thank you for delivering the content. I'm sure it was very handy, Jacek. We appreciate that.
Thank you.
All right.